To all of you joining me for this video, thank you. I am Mr. Ish. I hope everyone's having a great afternoon. The sum of the external angles for any polygon is always equal to 360 degrees, no matter the number of sides of that polygon. If you were to take a triangle and look at all of its measure of the external angles, look at them in the same direction, all of these external angles A, B, and C, A plus B plus C, they'll equal 360 degrees. No matter what the polygon is, the number of sides, the external angles is always equal to 360. Take a pentagon, we have that external angle, we've generated this, we've generated this, we've generated this, and that. Take all of these external angles, they'll always be equal to 360. How can you show that to be the case? It is very much verifiable. You can easily show it to be the case, and we will do that in this video. You are given only the definition of a supplementary angle, a number of angles which add up always to 180. Normally the norm is you have two angles, A plus B, they equal to 180, but it could be any number so long as they equal to 180. And then this formula here, you probably know this from your geometry, n minus 2 times 180. Any polygon, given the number of sides n, you can measure the sum of the internal angles by this formula. If you have a triangle where n is equal to 3, you do 3 minus 2 times 180, you get 180 degrees. That's why you know a triangle has 180 degrees. Internally, take a square or a rectangle or a parallelogram or even a trapezoid, a four-sided quadrilateral, you do 4 minus 2. The measure of the internal angles is always 360 degrees. You are given these items A and B, and you have to show the above topic headline here, the sum of the external angles. You have to show that to be the case. How do you do this? Well, how about this? Let n equal the number of sides we have. We're looking at a polygon which has n sides. We have to look at everything here with regards initially to this. This polygon has a certain number of sides. It has a certain measure of internal angles, and it is equal to n minus 2 times 180. Each side of this polygon has a certain angle. What is that angle? If you were to do n minus 2 times 180, that's the total measure of angles internally for this polygon of n sides, and you were to divide this by n, that's given you the measure of each angle. And that right there is the basis from where we will continue now. The measure of each angle for a polygon of n sides is n minus 2 times 180 divided by n. And you can see this right here is nothing out of the ordinary. We started with n sides. We use this formula to measure the total of internal angles. We've abbreviated here total of the internal angles by this. We have all that total, we divided by the number of sides, that gives us the measure of each angle. But each angle, you can visualize it. You have each angle. Suppose if this is an angle, each angle is in a supplementary relationship with an external angle. This internal angle plus another angle must equal to 180 degrees. What is that other angle? Well, that other angle can only be determined by using the definition of supplementary angles. A plus B equals 180. If this right here were supposedly A, you have a certain B over here, it would equal 180. You can determine this B right here to be 180 minus A, but A is all of this, n minus 2 times 180 divided by n. This right here now gives you the measure of each external angle. Think about it. It's now the measure of each external angle, because if you're taking one measure of an internal angle and you're using a supplementary definition to determine that external angle, you've determined the measure of each external angle. Now you've gotten this B value right over here. If you were to take this B value, because you're looking at measure of each external angle, you were to take B, let's use B, and you were to multiply by the number of sides of that polygon, and you should end up here with 360 degrees, and that will be the case. I have B over there. I just have to simplify it algebraically, and let me do that for you. If I take this simplified expression over here and I'll multiply it by n, I'll get 360 degrees. I have a common denominator that I can generate from here over here. I have 180 n. 1 goes in n times, minus, I can open up all of this. I have 180 n minus 360 all over n. This right here is still giving me the measure of B, because I'm simplifying what was a relatively complex expression. When I open this up, you look what happens. 180 n, the minus 180 n will cancel out, and this minus 360 will become a positive 360. I'll get B is equal to 360 over n. This right here is still giving me the measure of each external angle. We've just simplified an expression into something more appealing expression right there. It looks more easy, it looks more appealing. 360 divided by n. And I'm telling you here, b times the number of n sides will give you 360, and that's exactly what you will see. The measure of each external angle times the number of sides will give you 360, and you'll see that 360 divided by n times n, and you'll get 360 degrees. It cancels out, and you've shown it to be the case that the sum of the total external angles for any polygon is indeed always 360 degrees, and I've shown you that to be the case. Remember how it starts. You have the measure of the number of sides you have. N is the number of sides. You also have this formula available from geometry that the total internal angles for any polygon is n minus 2 times 180. This total internal sum of all those angles, if you divide them by the total number of sides, it gives you the measure of each internal angle. And right here, that's the measure of each internal angle. But this each internal angle is in a supplementary relationship with an external angle. You can easily determine that external angle by 180 minus that. That's why you have that. You simplify this and you're still getting 360 over n, which is the measure of each external angle. Multiply the measure of each external angle by the total number of sides, and that'll give you the total of all the external angles for any polygon, 360 degrees. And you can take any n-sided polygon and you can verify it. N equals 7, and you can work it through for a heptagon. You'll see everything will work out, and nothing over here is wrong. Everything here is very right. You can call it a proof, but this informal proof is there before you. Remember this: the sum of the external angles for any polygon is always equals to 360 degrees, no matter how many sides are in that polygon. And that's this video completed. Thank you. Have a great day. Bye.